Hi, this is actually the second video of a short mini-series on D3.js. In the first video, we had a look at what D3.js generally is and how it works. Now, in this video, we're going to dive a bit deeper into the data joining part of D3. We'll learn how that exactly works and what it means when you join data with DOM elements. So it's really important that you understand how data binding, or data joins as it's actually called, works in D3.js. Now, generally, whenever you see code like this, we're talking about data binding or data joins, and I'll use these terms interchangeably here. So what we're doing here, and what I showed you in the first video of this little mini-series, which you find linked below this video, is we're selecting all elements with a bar CSS class on it, and we're binding some data to those elements. Now, as you learned in that last video, in that first video, those elements don't need to exist yet. We can also bind data to elements that aren't rendered yet, so that we basically then tell D3.js, hey, please find the difference between what's currently rendered, maybe nothing, and what should be rendered based on the data. That's the whole idea here. So in the end, what we do here is we join some data with the selected bar elements and the data that is attached to those elements. And that data attachment thing is managed behind the scenes by D3.js. And more importantly than that, D3.js then also derives the required updates. It finds out what should be added, so which new data is available based on what was previously rendered and the data we now joined. What should be removed, so what is redundant based on what was rendered and what we now joined, and maybe what was there before, but what simply changed now. And it gives us the enter and exit methods on the selection generated by the data join to easily get access to the elements that are missing or that are redundant. And it will automatically update elements that are already there where the data changed. Let me show this to you to make this really clear. And for this, I have an empty project here, just a base HTML skeleton with some styles here, some basic styles, with an empty unordered list. And a script import, and I'm importing D3 min.js. I'm also importing D3 scale, but we're not going to use that here. So if you want to follow along, you can just use the normal D3 import. Now, here in app.js, so in my script, I now want to set up some data with which we can work. And for that, I'll actually create a new object, country data, which is a regular JavaScript object like this, where I want to have some items. And I'll keep the data set very simple here because I want to focus on how D3.js works. So let's say our actual data, which I store in items here, is just a set of country names. So something like China, India, and the US. And of course, you can add any countries you want. Now I'll also add some methods. I'll add an add item method here, which takes a new item that should be added, where I simply reach out to this items and I push my item onto this array. Then I want a remove item method, where I get the index of the element that should be removed, and I remove it by using this item's splice, not slice, but splice, to remove an item, and I remove the item at index, and only that item. By passing 1 as a second argument, I make it clear that I only want to remove the item at this index. And last but not least, I'll add an update item method. This takes the index of the item that should be updated and the new item that should be inserted in place of that existing item. And we simply select the item by index and replace it with new item therefore. So it's a very simple object with some simple methods, but this allows us to interact with this data here. Now let's use D3.js, and let's start simple. Let's say we want to output the data we have here in our DOM so that we can see it on our page here. Now for that, we use the D3 object, which is available thanks to the D3 import. And here we can first of all select the node, the element where we want to render our data in. And that's the unordered list in my case. So I select this with the select method, and the select method selects one single element, the first unordered list it finds. Now in that unordered list, I now want to add my data, and for every data piece, I want to render a list item. Therefore, here we do select all li. And even though we have no list items initially, we can select them. Of course, this selection will simply be empty the first time this runs, but this is what allows D3.js to later do this diff, this comparison between what is rendered and what should be rendered based on the joined data. Because that's going to be the next step. We call data on that selection, and that joins all list items in that unordered list with the data we're going to pass in here. And there I want to pass in country data.items, because my items array, that's the data I want to render. Now behind the scenes, D3.js will therefore then go ahead, have a look at the list items it found, and initially it didn't find any, have a look at the data, and basically check based on the data I got here, so based on the number of elements in the end here in this array, how many list items do I need to add? How many list items should I maybe remove? And which data did simply change? And the first time this runs, when we have no list items, there is nothing to remove, there is nothing to change or to update, but there are, of course, missing list items. So data here, in the end, gives us back a new selection, basically a selection full of the to be rendered elements. So data now basically holds information about what was rendered and which data we connected to this. And now from this selection, from that information, we can now extract different slices of information, so to say. For example, with the enter method, we can find out which items are missing. With the exit method, we could find out which items are redundant and should be removed maybe. Well, of course, since we know that initially we have no list items, we want to call enter. And this gives us a new selection, which now holds all missing list items. So which basically holds the information about which items were expected based on the data we joined, and which items were actually selected and therefore rendered before. And initially that means that here we have a selection full of missing list items. And we can then append those list items by calling append li. And this will now render a new list item for every missing data point. Now you could render anything here, you could render a div here, but that wouldn't make much sense, because when you then later again select all list items in the unordered list to maybe join new data, if you rendered divs for missing data before, those list items will still be missing in the future. So you should append here what you selected here. And this will now render new list items for all the data points here. And in order to see something, I can now render some text here. So with the text method, we can append or add text to every rendered list item. And there we could add some hard-coded text if we wanted to, but we can also reach out to the data of the data point of every specific list item. So we have one list item being rendered per data point here, and we can get access to the data in that respective data point. Now, our data points are just strings here, so therefore, in this function which we can pass in here, we get access to the data point, and I can just return the data in there because that already is a string. If it were an object, you could of course access some property of it. But here it's a string, so we can just return it like this. And if we now save that and reload, we therefore see these 3 countries being rendered. Now that's what I showed you before. Now let's understand this data joining a bit better though. Let's say that our data changes. Maybe because the user clicked a button, or maybe, like I'll do it here for demo purposes, because we set a timer. So here I have a timer of 2 seconds, let's say, and after 2 seconds I want to add a new item. So I can reach out to country data and call the add item method we added earlier, and maybe add Germany, or whichever country you want to add. And now we can basically repeat this step here. I can select all this code and execute it again. And with this, I again reach out to all the list items in the unordered list and join it with my new data. Since I call country data add item here, country data items here will be different than it was here in line 16, because now we have, well, new items in there. We added Germany after all. So now enter will hold the difference between the list items it found and the data that was connected to those list items in the past and the new data. Now here, of course, unlike before when we first rendered this, there will be list items. but D3.js will see that we only have 3 list items, but actually 4 countries now. So enter should hold that extra new data piece that was added. So we append a new list item for every missing data point, and again output the name of the country, so output the text here. And to make it a bit easier to see which country was added or which new data point was rendered, I'll actually add a class here with the classed method, and that's going to be the added class, which we add like this. That's a class I prepared in advance here. It simply renders a green background color. If I now save this and reload, initially we have 3 countries, but then Germany is added and it is green, as you can tell. Now interesting, if you open the Elements tab in your DevTools, if you reload here, you see initially 3 list items, and you see that only the 4th one flashed here. So that's also nice to know. When the data changes, D3.js is not going ahead and re-rendering everything. It really only re-renders what changed. And that's of course better for performance than if it would re-render the entire list. So that's an interesting side note. So with that, we added a new item. Let's now copy that whole timer and add a new timer, which let's say fires after 4 seconds here. And there, I don't want to add an item, but I want to remove an item. So I'll call remove item and remove the item at index 0. So the first item in the list, and that should be China. Now thereafter, again, I select all my list items and I join it with the new data. And now I'm not interested in the data that needs to be added, because that should be nothing, because I only remove something. Instead, with exit, we now get access to the redundant data. We get access to the information D3.js derived on which data was removed, for which we still have a rendered list item. And then we could call remove to remove such redundant DOM nodes. But here I want to do something else. Instead of removing it, I will actually just change the CSS class or add a new CSS class of redundant. And I'm doing this so that we can see on the screen which data changed. If I remove it, we also see what's missing, but this, since redundant adds a red or a reddish background, should make it easier to see what D3.js identified as redundant. We don't need to set a text here because we're working with DOM elements that already were rendered. So if we now save this, in a reload, we see after 2 seconds Germany gets added, but after 4 seconds, that doesn't make sense, does it? Germany is getting removed, but we removed the first item here. Well, good news is D3.js did identify some change. Bad news is it identified the wrong change. The reason for that is that currently I'm always joining my array of data here. And the thing with that is, if you do just that, D3.js identifies elements by index. Now, if I remove the first element in my array, that does not mean that the first element is empty. It means that all other elements move 1 position ahead. So India becomes the new first element with index 0, USA becomes the new second element with index 1, and Germany, which I added before, becomes the new third element with index 2. Now, because that is what's happening, what D3.js of course sees is that we have 4 rendered list items because we added Germany. So after this line or after this code block, we have 4 rendered list items. But after removing the first item, there only should be 3 list items. And D3.js by default is not going to look at the concrete values. Instead, it just checks the length of the new data array and of the old data array basically, and sees that there's a difference, so it simply gets rid of the last element in the array, or of the rendered elements to be precise. So that's why it identifies Germany as the redundant data, because the new data array, after removing the first item, simply has only 3 items instead of 4. Now, of course, that's not the behavior we want here, and thankfully, we can change it. We can tell D3.js how it should identify data. As I said, by default, it just takes the index in the array and doesn't look at the concrete data value, but we can change that. When we call the data method, we can pass in a second argument where we basically provide a function that returns the key that should be used for identifying data to D3.js. Here we get access to the concrete data points. So this function gets executed for every data point, and it should return some value which we extract from the data point that acts as a unique identifier of that data point. Now, since our data points are just strings here, I'm just going to return the string itself, like this. But with that, I'm saying it's not the index that matters for identifying data. Instead, it's the data itself, the string in this case. And therefore, D3.js now will make that comparison not by length of the array and by index, but instead by looking at the string. And it will compare strings. And we have to do that for all data joins, of course, like this. And if we do that, and we now reload, you'll see that Germany gets added, but then China gets marked as redundant data. And that is what should happen, and that is what happens because D3.js now does not just see that the data array length changed, and basically compares that to the amount of list items that were rendered, but it looks at the concrete values, and it checks which value is missing now. And that's, of course, the string China. So with that, let's copy that one last time here, because here I now want to call country data.update item. And let's say I want to update the second item, so the one with index 1, and change it to Russia. Currently, the second item here is India, though keep in mind that this timer here actually should run after 6 seconds, and therefore after we removed the first item. So the actual second item at this point is not going to be India, but instead should be the USA, because we removed the first item in the meantime. So I'm changing that item to Russia. Then I have my same code as before. I join my list items with that updated data. Now here in this case, I'm still interested in the data that exited, because when we update data, when I replace the second item with Russia, technically the old second item, India, of course exits. It's removed because it is replaced with new data. Of course, we don't remove a real element in our data array, but we do remove data in there. We replace it with new data. That's the difference to just removing it. But still, with exit, we can get access to this changed data. And just to be real clear here, this exit method, gives us information about the data which D3.js identified as being redundant now. But here in this case, we simply know that we replaced one item with Russia. And therefore, this item is not really redundant, but just changed. But that's something we know here. And why does the item we replaced end up in exit in the first place? Why is it identified as being redundant? Well, because we're using our data, our string itself, as a key. That's what we changed a couple of seconds ago. So if we replace USA with Russia, well, that USA key is gone and that Russia key is new. So therefore, we would find Russia on enter and USA on exit. But since we know exactly what we're doing here, we can of course also just use the exit data and not remove it and then add Russia, but instead just change the exited data. But again, we only do this here because we know exactly which change we're making here. And to mark it as such, let's add the updated class here. To mark it as updated, because that is a nice class I prepared that gives us some orange background. With that, if I reload here, we see Germany, China, and then you see the US gets marked and China gets marked. Now, the US makes a lot of sense because I'm updating the second item, which at this point, because we removed the first item before, which at this point is the USA, as I explained. So it makes sense that this gets marked. But why is China getting marked? Well, keep in mind, we did remove China here, right? We do remove it here. But we don't remove it in the DOM. I just mark it as redundant. But when we then here, again, select all list items and join that with our updated data, in that data, China is still missing. We still have that same data set where we removed China. So therefore, of course, the difference detected by D3.js is that, yes, the US changed to Russia, but also China changed. Compared to what's rendered in the DOM, China changed because we never removed it. If we would have called remove here in the removal case to really remove the DOM node, of course, only the US will be marked. So now you see Germany is added, China is really being removed, and then only the US is marked as updated. So that's the only reason why China shows up again. Now I'll not remove it here because I like this red effect where we mark what's going to be removed, what is identified as redundant, but that's the explanation why the same item later gets marked as updated. Now what you'll also notice, of course, though, is if I reload again, we have Germany, we have China, and the US gets marked, and China for the reasons mentioned, but the text here on USA does not change. But we did change it here. Well, that makes sense, hopefully, because D3.js is not going to magically change our DOM. It only does what we instruct it to do, like, for example, add this class. So if you want to change the text here, you have to call text and set this to Russia, for example. You can also set it to data, so to this function that gets access to the data point and uses the data point's value as a text. But with that, you actually would get access to the data point that is marked as to be removed or as redundant. So you would get access to USA as a text, not to Russia. And therefore here, since we of course know that we're going to add Russia, we should hard code it here. So now if I reload here, you see Germany is being added. China is marked for removal. And then we have Russia here and also here because, well, China is still sticking around, right? But this is now the update which we want to perform. And that's how D3.js data binding or data joins work. Especially the exit and the enter case are super important to understand because these are the cases you're typically working with a lot. This second argument you can pass to data to provide a unique identifier to D3.js for your data points. That's also good to know. And in general, hopefully that video helped with understanding how D3.js works and how you connect your DOM nodes to data with D3.js.